Pseudocode for job sequencing. In the last lecture, we learned about job sequencing problem and the greedy algorithm that can be used to solve job sequencing problem. Here, we are going to look into the pseudocode for the greedy algorithm that we learned in last lecture. So as we explained in the previous pseudocode lectures, we'll be trying to come up with a pseudocode which is very close to the syntax used in multiple programming languages, but we won't stick to any particular programming language so that you can easily refer to this and convert to whichever programming language you may want to. Okay. So we are going to write the pseudocode for this. First of all, what is the job sequencing problem that we learned in the last lecture? We'll be given n jobs and each of the jobs will be having profits and deadlines, and the task is to find those jobs that are to be scheduled in the allotted time slots so that your profit can be maximized. That is, total profit can be maximized. We know the number of slots won't be good enough to put all the jobs in. So you have to select those jobs which can be scheduled in this time slot, right? So for this, what is the algorithm that we explained? In the algorithm that we explained, first you have to sort all the jobs in the descending order of profits. So once you sort in descending order of profits, you will have the job which is having maximum profit as the first element, job which is having second maximum profit as the second element, and so on. Next step, second step is to create an array of time slots, and the third step is to insert jobs into this array of time slots. So you will be looking into the jobs which are sorted in descending order of profits. You will take each job. You will see if you can schedule that job in these time slots. This is considering the deadlines. So what will you do there? You'll try to start from the time slot which is corresponding to this deadline. If that time slot is available, you will put it there. If it is not available, you'll check each of the time slots towards the left. So whichever is the first available time slot, that is where you are going to insert it. And finally, you want maximum profit. So let us write an algorithm for this. For detailed explanation on the algorithm, please refer to the last lecture. Here we are mainly focusing on the algorithm, pseudocode, right? So job sequencing, let us write a function, job sequencing. And what is the input? Let us say input is an array of tuples. So in this array, we'll have deadlines and profit for each job. This is what each element of the array will be. So let us say this array is the input we are having. What should you do first? First, you should sort the jobs. So first step is to sort this array in descending order of profit. So this is the first step that you have to do. Let us say array.profit. So once you sort it, whichever array you are having, this will now be organized in the descending order of profits. So whichever job is in the first position of this array will be having maximum profit among all these jobs. We also know each of the job will take only 1 unit of time to be done, and at any point of time you can only schedule one job. So these are the rules that we already explained in the last lecture. Next thing is, what should be the size of arrays that you want to initialize? See, ideally you can initialize the slot arrays with size of maximum among the deadlines. Among the deadlines, whichever is the largest value, you can ideally only need an array of that size. But here we'll be taking of the size of n because we are generally expecting that deadlines will be of the order of n, right? So we already discussed why deadline cannot be more than n in any case in the last lecture. So first thing, we'll have a slots array. So let us say slots array. So slots array is an array of size n. So n is the size of this array. N is the size of this array. So, okay, let us say I'm just initializing an array, okay? False size n initialized with values false, okay? So this is a Boolean array which I'm initializing. Each of the element is initialized as false. Why am I doing this? This array I need just to keep track of which are the slots that are already used and which are the slots that are available. So initially I'm making each of the element as false. This is a Boolean array which can either be true or false in each of the indices. So if it is false in all, that means all the available slots are empty. Whenever I fill a job, I'll make it true, which means that particular slot is not available. Okay. So the next thing is I need one more array in which I'll schedule all the jobs. So let us say I'm calling it jobs array. This is also of the size n because n is the total number of jobs I have. So this is where I'll be actually inserting all the jobs. Okay. So this is also empty. Okay. This is an empty array to start with. So once I have both these arrays, what is the next thing? Next thing is I want one variable in which I'll have track of total profit. So total profit till this point it is 0. And once I start looping into all the jobs, I'll increase my profit. So let us say I'll go through all the jobs for I is equal to 0 to till which point should I go? Length of array minus 1. So length of array minus 1 means from first job till the last job. Keep in mind this array is already sorted in descending order. And inside that, let us say I'm considering the first job in that. What should I do? For, let us say this time j is equal to array of I dot. I want to see whatever is the deadline of this particular job. And from that deadline till the first slot, that is 0, from the deadline till the first slot I will traverse, and whichever is the available slot I'll insert it there. So let us say from ar of I dot deadline minus 1 to 0. Why is that minus 1 here? Because we are using 0 indexed array and we are having slots from 1. So that whatever is corresponding to slot 1 will be put in slot 0 because our array is having index 0, right? So from the deadline of the first job, that is job with maximum profit, we are trying to take the deadline of that. From that point in the time slot array, we are going to traverse backwards and see whichever is the first available slot. So inside this, what should be the condition? If let us say our slots array, we are having a slots array in which we are keeping track of whether that slot is available or not. So if slot of j is equal to, let us say, false. If slot of j is false, that means this particular slot is available. You can insert in this point. So if it is available, what will you do? First thing is you will make slot of j is equal to true. Next thing is you have jobs array. Jobs array also you initialized as an empty array. Jobs of j is equal to whatever is your job. So ar of j. This job you will insert into the jobs array. So you can either insert ar of j or you can just put a flag that will, instead of flag, some variable or something that will denote that it is this particular job. Okay. Next thing is your total profit. Your total profit can be whatever is your present total profit plus the profit that you gain from this job, that is ar of j dot profit. And once you're done with this, let us say you found the slot, you need not continue this particular loop, so you can break it. So till the point you find the slot, you will continue this loop. Once you find the slot, you will break out of this inner loop. In the outer loop, you are going through each of the jobs, and in the inner loop, you are going through each of the slots that are available. So for each of the job, you will be going through the slots only till the point you find the slot. If you find the slot, you will break and come out of the inner loop, and again you will continue the outer loop. So in outer loop, you will pick the next element. Again, you will enter the inner loop, pick a slot for this, and so on. So this is what you have to do. And finally, whatever you want to return. So once you are done with this, you can, let us say, return. This is once you come out of the outer loop, you can return total profit. And if you want to return this jobs array, that can also be returned, whether the jobs array or the total profit that you want. So this is the algorithm that we have for job sequencing. What did we do in this? Initially, we sorted all the jobs that are given in descending order of profits. Then we made two arrays. First thing is an array for keeping track of whether the job is already scheduled in that slot or not. So this is a Boolean array, simply says true or false for each of the time slot. Next thing is for arranging the jobs, we have one more array. This is initially initialized to as an empty array. Next thing, we are having a total profit variable which will keep track of the total profit we have till this point. So coming to time complexities, this sorting will take order of n log n time. This is the maximum time activity till this point. All these won't take much time. So this will take order of n only. Next thing is, once you enter this loop, you are going through this loop for every single job. So order of n is the time just for the outer loop. And inside each of that operation, what are you going to do? You will go to the inner loop and check for the best available slot. So in this, again, you are looking through each of the slot. Worst cases, order of n. You may have to go through all the available slot, and that is the worst case. So order of n times you are going inside, and inside you are again doing order of n work, which is a total of order of n square. So time complexity of this algorithm is order of n square. And what are you doing in the inner loop? Inner loop, you will check whether this particular slot is available. If it is available, you will make this slot as not available, and then you will add this particular job into the scheduled list, and then you will update total profit that you got till this point. And once you are done, you can break out of this loop and again continue with the next job here. So the time complexity is order of n square. What is the space complexity? So in terms of space complexity, you are using two arrays here, because of which you are taking order of n time each and space each. So space complexity is order of n for this algorithm.